When organizations say they have a standard process, what do they actually mean?
Well, I mean, that is the million-dollar question, isn't it?
It really is. Because if you picture a state-of-the-art chemical processing facility, we are talking about millions of dollars invested in automation.
Oh, absolutely.
Pristine binders of standard operating procedures sitting in the control room, digital dashboards tracking pretty much every conceivable metric.
Right? It looks perfect on paper.
Yeah, exactly. Yet, if a 62-year-old shift supervisor named Jim happens to, I don't know, catch a severe flu and takes a week off, the entire production line quietly starts missing its output targets.
Which is terrifying for any executive.
It is. And today we are unpacking that exact paradox.
No.
Welcome to our deep dive into the source material. We're examining a pretty formidable stack of executive insights, consulting reports, so we've got extensive data from BCG, Deloitte, Atlan, Haptic, and Sizag.
Plus a lot of really fascinating field notes.
Right. And for you, our executive listener, the mission today is to explore this massive, hidden operational bottleneck. Basically, organizations that unknowingly depend on undocumented expertise.
And the macroeconomic context here makes this a remarkably urgent conversation.
How so?
Well, if you look across manufacturing, energy, the broader process industries, we're basically standing at the edge of a severe talent cliff.
Yeah.
The actuarial data is it's unavoidable.
Yeah.
10,000 of the so-called boomer generation are retiring daily across the industrial landscape.
Daily. That is a staggering number.
Right. And they are taking their pensions, obviously. But more critically, they are taking decades of unwritten, highly nuanced operational knowledge right out the door with them.
Stuff that isn't in the manuals.
Exactly. We are talking about the subtle adjustments, the mental troubleshooting trees, the instinctual problem solving that actually keeps complex operations running.
Okay, let's unpack this. Because to really understand the mechanics of this vulnerability, we need a framework, right?
We do.
And the Lean Enterprise Institute's concept of standardized work serves as really the perfect lens here. If we look closely at their definition, it helps illuminate exactly why companies so frequently and dangerously mistake highly capable people for robust organizational processes.
Yeah, establishing that fundamental difference between a standardized process and an experienced workforce is the necessary starting point.
But they are not the same thing.
Not at all, but they are consistently conflated in executive dashboards and boardrooms. I mean, think about a typical manufacturing line.
Yep.
The physical machinery is completely unchanged. The raw materials feeding into the hopper unchanged. The documented standard operating procedure, the official SOP, is exactly the same as it was yesterday.
Right.
But when a key individual goes on leave, the outputs begin to fluctuate.
The cycle times start to drift. And, for those of you listening who might operate slightly outside the manufacturing floor, when we say cycle times, we mean the total time it takes from the beginning to the end of your process to produce one unit. So one day, a unit takes 5 minutes to make, and the next day, with Jim out sick, it takes 8 minutes for literally no mechanically visible reason.
And quality outcomes drop in tandem with those drifting cycle times. Unexplained variability just sort of appears in the output.
Which shouldn't happen if the process was actually standard.
Right. If the process itself were truly standardized and robust, the absence of one individual would not create that kind of systemic ripple effect. I mean, the machine doesn't know the supervisor is on vacation.
No, it doesn't.
But the process behaves as if it does.
Which is wild. And if this expert trap, as the field notes refer to it, is this dangerous, it begs the question, why do managers let it happen?
That's the thing.
Can't be intentional negligence,
That's
right?
correct.
A process appears highly stable for years, not because the system itself is inherently robust, but because highly capable individuals are continuously, quietly compensating for the system's weaknesses.
Yes.
How does an entire factory floor quietly agree to just ignore the official handbook?
Well, that compensation happens almost entirely invisibly. That's the trick. Management looks at a KPI dashboard. At the end of the month, they see a wall of green lights indicating targets were met, and they naturally assume that the underlying process is standard and optimized.
They see green, they think standard.
Right. But what they actually have are standardized outcomes being delivered by human memory and individual heroics. The system is broken, but the people are so good they hide the break.
Every plant has at least one process that is technically documented and practically inherited.
It is so true. The auditor walks through the facility, sees the binder, checks the box, and just moves on.
Yep.
The documentation exists solely to satisfy that audit. But the actual work on the floor, That's executed based on muscle memory and tribal knowledge passed down from operator to operator.
But let me push back on this for a moment, just to play devil's advocate.
Sure.
If I am a plant manager, Jim's undocumented expertise might be the only reason my most demanding client is actually happy. If the outcome is good, the quality is high, the widgets ship on time, why should I care if the specific sequence of actions lives entirely in Jim's head?
Yeah.
I mean, are we just punishing people for being exceptionally good at their jobs? Why disrupt a system that is currently winning me business?
Because a system built on one person's memory simply does not scale. And it introduces a terrifying level of fragility into your operation.
The risk factor.
Exactly. The Deloitte data provided in our sources brings this into really sharp relief. Currently, 47% of organizations explicitly identify key person dependency as a major operational risk.
Wow, almost half.
Right, and that is up from 34% just back in 2020. Nearly half of the industrial landscape has realized that their core operational stability is tied to specific individuals rather than the organization itself.
So it's not a scalable asset.
Exactly. If you want to open a second facility, Jim cannot be in two places at once. If Jim retires or, takes a counteroffer from a competitor, your working system evaporates overnight.
That jump from 34 to 47% in just a few years is super telling to me. It suggests that as supply chains got tighter and margins got thinner post-2020, companies realized they didn't actually own their processes.
No, they didn't.
They were essentially just renting the expertise of their most tenured staff.
That's a great way to put it. And the goal of highlighting this is absolutely not to remove human skill or craftsmanship from the floor.
Right, we're not trying to turn people into robots, no.
The goal is to prevent that human skill from becoming a catastrophic operational dependency. Tribal knowledge is, it's like relying on a local cab driver who knows all the back alleys to avoid a traffic jam.
Okay, yeah.
It is incredibly efficient right up until that specific driver calls in sick. Standardized work, on the other hand, is building the GPS system so anyone can drive the route successfully.
I love that analogy, which brings us to how this undocumented reality actually develops in the first place.
Yeah, the mechanics of it.
Yeah, because looking at the data, it rarely happens through deliberate sabotage or, a conscious effort by workers to hoard information to protect their jobs.
Rarely.
It happens organically through learning by doing and social transmission over years and decades.
And the Atlan source material provides a brilliant breakdown of the anatomy of this tribal knowledge. They categorize it into distinct types that are incredibly recognizable in real-world industrial applications.
Walk me through this.
First, you have process knowledge. These are the unwritten sequence adjustments. So, the official documented procedure might dictate starting equipment A, followed immediately by equipment B.
Right.
But the veteran operator knows that if you don't let equipment A warm up for exactly 4 extra minutes, the internal sensors miscalibrate and the whole line jams.
Oh, wow.
That crucial 4-minute adjustment is never written down. It is just absorbed into the daily routine.
It's the physical workaround that just becomes the new invisible standard.
Exactly. And then you have interpretive knowledge. This one is uniquely human. It is the ability to read a machine's mood or interpret ambiguous signals that the manual just doesn't cover.
Right. Reading the room, basically, but for machinery.
Yes. The SciZag report details this perfectly. It is the pump that behaves slightly differently in the summer due to ambient humidity. Or consider the concept of an ingestion lag.
What's that?
So a junior technician might look at a monitor, see a 20% drop in pressure, panic, and initiate an emergency shutdown.
Because the manual says 20% is bad.
Exactly. A senior operator looks at the exact same monitor and knows that they just fed a new batch of raw material into the system. And that 20% drop is simply an ingestion lag. The machine is momentarily digesting the new load, and it will correct itself in 3 minutes.
So the junior tech follows the safety manual to the letter and costs the plant 6 hours of downtime.
Yep.
The senior tech ignores the manual, relies on interpretive knowledge, and saves the shift.
That's it, exactly.
It is so easy to see why tribal knowledge becomes the preferred operating system. And that leads directly into the third category, right? Exception handling.
Yes, exception handling. This is about the messy reality of the plant floor that the ideal state documentation never accounts for.
Right, because traditional standard operating procedures capture what engineers call the nominal steps.
The happy path.
Yeah, they describe the ideal state of the operation in a vacuum, assuming perfect raw materials, perfect temperature, perfectly functioning tools.
Which never happens. Tribal knowledge is entirely about contextual judgment. It
Yeah.
is knowing how to handle the deviations, the degraded states, the imperfect material batches that arrive from a new supplier.
It's funny. Sometimes the procedure starts on paper and finishes in conversation.
What's fascinating here is how this dynamic actively undermines formal onboarding.
Oh, absolutely.
When a new trainee looks at the official SOP
Hmm.
and then asks a senior operator how to actually perform the task, the standard response across almost every industrial setting is, well, watch Priya do it, or John knows the real sequence.
Right. Just ask John.
The official document is immediately culturally overridden by the socially transmitted tribal knowledge.
And this isn't just a quirky cultural artifact of the factory floor. I mean, we aren't just talking about the theoretical risk of a catastrophic equipment failure,
Yeah.
though that risk is very, very real.
Oh, it is.
We are talking about a daily, grinding friction of lost knowledge that bleeds the balance sheet dry.
The financial impact is staggering when you aggregate it. According to the data in our sources, unplanned outages cost global industries $1.4 trillion annually.
Trillion, with a T.
Trillion. But beneath that massive headline-grabbing number is a more insidious daily drain. 75% of manufacturers report moderate to severe shortages of skilled resources.
Which is huge on its own.
Right, and that specific shortage directly translates to an average 11% loss in annual earnings.
11% of earnings just gone. Let's look at the BCG maintenance talent crunch data to see how this actually plays out in real time on the floor.
Good idea.
Because they observed facilities where junior technicians take up to 3.5 times longer than their experienced counterparts to perform routine maintenance tasks.
3.5 times longer is a devastating metric for plant efficiency. And we have to ask why they are taking so much longer.
Right. It's not because they are inherently slower.
Or lazier. It is because they lack the context. They are spending that extra time troubleshooting dead ends, gathering information that isn't documented, physically searching for the right tool that isn't listed in the manual.
Just flying blind, essentially.
Yes. Verifying quality without clear parameters, and inevitably performing rework when they guess wrong.
And BCG notes that this delay alone can lead to a loss in plant availability of approximately 25%.
A quarter of your capacity.
You are losing a quarter of your operational capacity simply because the knowledge isn't accessible to the person tuning the wrench.
It is wild, and the stakes escalate dramatically when we examine the Kahuna workforce data on chemical plant turnarounds.
Yes. And for you listening who might not deal with heavy industrials daily, a turnaround is an incredibly high-stakes, planned maintenance event.
Very high stakes.
A refinery or chemical plant will completely shut down operations for weeks to perform deep maintenance, upgrades, inspections. It requires bringing in hundreds, sometimes thousands, of outside contractors.
It's a massive logistical undertaking.
Right. And Kahuna notes that these events can consume 50% of an entire annual maintenance budget in just 1 month. Yet, a staggering 68% of them fail.
68%.
Meaning they go over budget, they push past the scheduled time, or they just fail to complete the planned scope of work.
And they fail at such a high rate because staffing for these critical, highly capitalized events is largely based on the tribal knowledge model.
Interesting. How so?
Well, instead of utilizing validated objective skills data, planners are operating on the assumption that certain foremen, quote unquote, know how to do it.
Right.
Or they treat external contractors as general purpose workers, assuming a pipe fitter from one state understands the undocumented quirks of a specialized catalytic cracker in another state.
Which they won't.
Exactly. They are not matching specific, validated capabilities to specific high-risk work orders.
The succession plan occasionally involves hoping someone took notes.
Yeah, that's exactly what it is. When you treat operational competency as a vague assumption rather than a validated data point, human error becomes the primary driver of rework and delayed commissioning.
Because it's all guesswork.
Right.
Right.
If you are staffing a turnaround based on tenure, reputation, or just who happens to be available rather than documented capability, you are essentially gambling with half of your annual maintenance budget.
Just on the hope that someone remembers how the system was reassembled 5 years ago.
Yes.
Here's where it gets really interesting. If we look at the BCG and Atlan data regarding the incoming AI era, this issue of tribal knowledge transforms from, a human resources headache into a hard technological bottleneck.
A massive bottleneck. Because BCG's microeconomic modeling reveals that over the next 2 to 3 years, 50 to 55% of U.S. jobs will be fundamentally reshaped by AI integration. So the obvious modern solution here for most executives is just to automate it, right? Throw an AI agent at the production line so we don't have to rely on Jim's memory ever again.
You would think that is the silver bullet. But the Alan report shows exactly why that assumption is currently a recipe for operational disaster.
Really?
For decades, tribal knowledge was a human-to-human problem. When a process was poorly documented, human operators could naturally compensate.
Because they're human.
Right. They can ask questions, they can use their contextual judgment, they can escalate to a supervisor, they can literally read the context of the room or hear a strange vibration in the floorboards.
And AI can't do that.
AI agents cannot do any of those things. AI requires structured, explicit, and objective inputs.
So let's unpack the missing exception scenario from the Alan report, because I think it illustrates the mechanism of this failure perfectly.
It really does. Imagine you deploy a sophisticated AI agent or an automated pipeline on a process that relies heavily on those unwritten rules we discussed earlier. The AI will ingest the official, nominal documentation and follow it flawlessly.
Flawlessly.
And because that documentation is missing the exception logic, the reality of how the plant actually runs the AI will fail silently.
It will produce outputs that are technically correct according to the incomplete data it has, but organizationally completely wrong.
Technically correct, but operationally a disaster.
Exactly. The Atlan source points to Gartner data indicating that 60% of AI agent production failures trace back directly to these context quality issues.
60%.
If the AI doesn't know that a specific flow metric drops 20% every Tuesday afternoon because of a downstream batching process, because that fact only lives in Priya's head and was never added to the SOP, the AI will perceive that drop as a catastrophic failure.
It's going to freak out.
It will sound alarms, generate false positives, and potentially initiate automated emergency shutdown.
Yeah.
You simply cannot automate a process that exists primarily in someone's mind.
Which brings us back to our foundation.
Yeah.
We need a way out of this trap.
Yeah.
And the Lean Enterprise Institute defines standardized work as the current best-known method for performing a process.
Yes. And it is a critical, multi-layered definition, current, best-known method.
Right.
It acknowledges that the standard is not static. It is meant to evolve. But it must be established as a visible baseline first.
You have to know where you're starting.
Crucially, documentation in the lean sense is not bureaucracy. Standardized work is not about turning highly skilled creative people into mindless robots reading checklists.
Right.
It is about making successful work visible to the entire organization so it can be repeated safely, trained effectively, and improved upon collectively.
Because you cannot improve the secret. If Jim's method is the best, but nobody knows what it is, the organization cannot adopt it.
If we connect this to the bigger picture, we have to look at the transition from static standard operating procedures to what the haptic source material defines as operational memory.
Operational memory. I love that term. Because a 3-ring binder sitting on a shelf in the supervisor's office doesn't help the junior technician lying under a leaking valve at 2:00 a.m. on a Sunday.
No, it doesn't. And operational memory has 3 distinct mechanical characteristics that separate it from traditional static documentation.
Okay.
First, it must be workflow-based. The knowledge cannot be a reference material you seek out. It must be embedded directly into the flow of the work itself, guiding the execution sequence seamlessly.
So it's right there when you need it.
Exactly. Second, it must be decision-aware. It has to capture the escalation logic. It must define the thresholds and the exception rules, clearly telling the operator exactly what to do when the raw material is slightly out of spec or the core temperature is drifting.
Got it. And the third characteristic is that it must produce evidence naturally at the point of work.
Yeah.
And I want to make sure we explain the mechanism here for the listener.
Good point.
When we say it produces evidence naturally, we are not talking about forcing a mechanic to stop every 5 minutes to check a box on a clipboard.
No, definitely not.
Think about a smart torque wrench connected to an industrial augmented reality headset. The operator is guided to the exact bolt. The wrench physically will not release until the exact required torque is hit, and that completion data is instantly, automatically logged to the central system.
Right.
The tool itself is enforcing and recording the memory without adding bureaucratic friction.
A surprising amount of operational continuity relies on knowing who to call.
So true. When things go wrong, the unwritten procedure is usually call Jim.
Exactly. And true standardized work, true operational memory means you don't have to make that panicked call at 2:00 a.m. because the contextual judgment of the expert has been embedded into the workflow itself.
The system guides the junior technician through the exact same troubleshooting tree that Jim would have used.
Precise.
So what does this all mean? For you, the executive listening to this, how do you actually translate these insights into concrete structural action within your own operation?
That's the key.
Based on the synthesized sources, we have distilled this into 3 core takeaways for you.
Yeah.
1 insight, 1 diagnostic, and 1 action.
Let's start with the insight. Documentation is not bureaucracy. Documentation is operational memory.
It's an asset.
It is the launch pad from which all continuous improvement must launch. Without a visible, standardized baseline, training is inherently inconsistent, problem-solving is entirely subjective, and continuous improvement is mathematically impossible.
Because you cannot improve a process you cannot clearly measure or see.
Exactly.
Next is the diagnostic, which the field notes refer to as the memory dependency check. And this is something you can initiate today. Look at one recurring critical operational process in your facility and ask this very specific question. Can a trained newcomer perform this process successfully using only the documented method?
And you have to be brutal in your assessment here. Are the critical machine settings and physical sequences clearly visible in the document?
Right.
Are the most common operational exceptions and weather-based variations documented? If your most experienced, reliable operator was unexpectedly unavailable tomorrow, what would actually change on the floor?
Be honest with yourself.
If the honest answer is that efficiency would immediately drop, quality would drift, and emergency radio calls would spike, then that process is dependent on human memory, not organizational standardization.
Which means you have a vulnerability.
Yeah.
Finally, the action. Identify just one process that your diagnostic reveals is heavily dependent on a single person's expertise. Sit down with that person and do a focused 30-minute capture of their knowledge.
And you do not need to write a comprehensive textbook here. Capture the actual sequence they use, not the one they were taught 10 years ago.
Right, the real one.
Document the specific settings they rely on, the informal quality checkpoints they use to gauge success, the decision points where they adjust their approach, and the common exceptions they encounter.
Keep it practical.
Perfection is not required in this initial step. Visibility is required. You are taking the invisible and making it visible.
It is about transferring the intellectual property of your operation from an individual's mind back into the organization's infrastructure.
This raises an important question.
Yeah.
If we look at the trajectory of industrial AI and extended reality, as discussed in the Augmenteer and BCG reports, we have to wonder about the fundamental design of the next generation of industrial equipment.
Where's this all heading?
Exactly. As these technologies mature, will the equipment be designed to actively observe its human operators?
Oh, interesting.
Instead of humans manually sitting down to write out SOPs or record video tutorials, the machines and the embedded AI agents themselves might learn the tribal knowledge simply by watching an expert's physical workarounds, their pacing, and their decision-making patterns over time.
So the system would auto-generate the operational memory based on actual successful execution. The standard wouldn't just be a static document. It would be mathematically derived from human ingenuity in real time. That is a massive paradigm shift.
Experience should be one of an organization's greatest assets.
It should not become one of its greatest operational dependencies.
The question is not whether someone knows how to perform the process.
The question is whether the organization does.